Well, folks, we're back.
Yes.
Dr. Boyer and Mr. Bergmann, and we are going to be talking about the last part of this whole prehistoric astronomy stuff.
Yes. But now we're going to do it in our backyard.
So what can you find out about stars by just going in your backyard? Now, it'd be cool if you were like this kid right here and you had your own telescope. That'd be cool. You may or may not have one, but you can actually learn about stars with just your eyes. Yep. Maybe a pair of binoculars.
A pair of binoculars would be wonderful,
you can do some cool stuff with them, too. So today, backyard astronomy, what do you find inside or outside your backyard? All right, so what do you see in the sky now? So why don't we do a little video clip and so we're making this in January of 2011, and so let's see what the stars look like out in our backyard today.
Yeah, just go outside tonight, look up, and you'll see the same thing.
And we'll show you what they look like.
Beautiful.
All right. Well, one thing that you were seeing, and as you were showing us that, Dr. Boyer, is there are lots of different constellations up in the sky.
There are.
And when we talked about the zodiac last time, those are constellations that follow along the ecliptic, right? That's that path of the sun that kind of runs like that, right? But there's also other constellations that are not on the zodiac.
That's right.
And those have a big word, the asterism.
Asterism.
They're groups of stars that may or may not be part of a constellation.
Exactly.
So they're there, but they're not actually a constellation.
You can do it yourself. Just look up in the sky and say, those group of stars look like something. That's an asterism. Yeah. You just did one.
There you go. It doesn't have to be.
It's not official, but hey, you can do it.
But they're official ones, but who cares? You don't necessarily have to know all that.
That's right.
So
there's
now
one.
The ones that you probably have heard of are the Big Dipper. So
yeah.
You can find the Big Dipper in the sky.
Where
is the Big Dipper, Dr.
It's located very close to Polaris, the North Star.
So way kind of like straight up almost.
No, well, from where we're standing, it's actually over there.
So what does there mean?
Well, from your point of view, look towards the north.
To the north.
And then look up from the horizon, about 45 degrees. And approximately there you're going to see the Polaris, the North Star. And then from there you look around it until you can find the Big Dipper.
That kind of looks like, I'm going to see if I can do this right. Like that?
Yeah, there you go.
And here's the Big Dipper. Right?
Looks like a dipper. That's how it got its name. Now, it's had a lot of names over history.
Oh, really? I didn't know that.
And of course, it's part of what we call Ursa Major, the Big Bear constellation.
Oh, so it's part of the Bear constellation.
Yeah.
Very cool. Okay. And then there's some other ones. If you go to the southern hemisphere, there's the Summer Triangle.
Summer Triangle.
So in the summer, you can see this. And you know what we're going to do is we're going to, Dr. Boyer is going to take us to Peru. And he's going to go to Peru, and he's going to show you what the stars look like in the southern hemisphere. So we'll do that with our cool computer program.
It's different, yes. This is Dr. Boyer, and I wanted to talk to you today about constellations. But in particular, I wanted to talk about the winter constellations that you can see in the night sky right now. Now on the screen, what I have is a program called Starry Night. And if you want to get a copy of this, see Mr. Bergmann or myself, and we can loan you a disk, and then you can load it onto your computer, and you can have a copy of this to use too to identify constellations in the sky. Now, if you notice right here, we're on January 26th, which is today, at the current time, and what we're doing is looking at what you would see in the sky, provided that you could spot them. And so this morning at about 7:15, what you could see as you're looking south is the planet Venus right here. And Venus turns out to be one of those interesting stars you can only see at certain times of the year, and only when it gets far enough above the horizon that it's not blocked out by the sun. You're going to see it at sunrise now coming out of the southeast, as you can see here. And over here, of course, is the moon. Now, what I'm going to do is I'm going to set the time to go 3,000 times faster than what it normally is, and we're going to let the sun rise right here. And then we're going to go into the afternoon, and then we're going to go into the evening hours, and we're going to stop this thing at a point at which you can see some of the most famous constellations in the night sky. And I'm going to stop it right now. And this is the key constellation right here. This is Orion. And Orion is well known because when you look up at the sky, and you can see this is 9 o'clock at night, there are 3 stars in a row, due south. That's called Orion's belt. And then in the upper left-hand corner right here is the famous star Betelgeuse, which is a red giant. And in the lower right-hand corner here is Rigel, which is a blue giant. Now this is very easy to spot, doesn't take anything at all, just look due south, up a little bit from the horizon, and boom, there is Orion. Wonderful. Easy to spot, easy to see. What else is there to see in the vicinity of Orion? Right here is the star called Sirius. And Sirius is the brightest star in the constellation Canis Major, and it is the brightest star in the sky that you can see with your eye. Over here, we have another star right here, is Procyon, and this is associated with the constellation Canis Minor, the little dog. So Orion, the hunter, has his big dog, his hunting dog, and then he's got his little puppy right here that is acting as a follow-on to get his training so he can become a famous hunting dog like the big dog, Canis Major. Now if you continue looking up, then what you'll see over here is a pair of stars up and to the left, and these are the Gemini twins, and this is the star Castor, and this is the star Pollux, and they make up the constellation Gemini right here. And then if you go over here, you're going to see the star Aldebaran. That is the brightest star in the constellation Taurus. And you can see that you've got famous constellations in the vicinity of Orion that makes it very easy to see. Now suppose it wasn't so obvious what these are. I want to put some boundaries here. And these boundaries are imaginary boundaries that surround the major constellations found in the sky. Now if you didn't know, there are 88 named constellations in the sky. And this shows you the grouping of those stars. So here would be Orion, the big dog, little dog, Gemini, and this is Taurus the Bull's constellation inside here. Now let's go to look due north. And so I'll let Starry Night take us from due south to due north. And I've left in the boundaries for the constellations. And as we go over here, this star right here is Polaris. That's the star about which all of the constellations rotate at night. And over here is the Big Dipper, called Ursa Major, the Big Bear. And these two stars right here are called the pointer stars, and they point directly towards Polaris. And then Polaris is the end star in the constellation right here, which is the Little Dipper, also known as the Little Bear, Ursa Minor. And then over here is the famous W, and these stars right here represent Cassiopeia, the Queen. And then inside here is Draco the Dragon, who wraps himself around the bear, Little Bear, and Polaris. Over here is Cephas. This is known as the King. And then over here we have the constellation. I'll bring it up here. There we go. Camelopardalis, which sounds like maybe we've got a camel here, but in fact what it represents is a giraffe. And these are known as the circumpolar constellations because they're always visible in the night sky no matter what time it is. That's because they circle around Polaris as the night goes on. So if we were to let the time scale move, you can see indeed that the circumpolar constellations do in fact rotate in a counterclockwise fashion around Polaris, the pole star. So let's go back to the south again, and let's see what we can find here. And you notice that because the time has gone on where we're getting some light here and we're starting to move into sunrise, that we're starting to pick up some daylight hours. And sure enough, there's Venus as the sun is rising in the morning. So if you want to see Venus, and it's not seen very often, then you need to get up bright and early in the morning just before the sun rises and look off into the southeast and you will find Venus. So I hope you enjoyed this little introduction to the night sky. The winter constellations are the most magnificent constellations to see, the easiest to see, and in class we'll be studying these constellations, and you'll be expected to go out and find these so that you can identify them on your own and perhaps maybe identify them on a test.
Now, one of the stars, Dr. Boyer, is really important, isn't it?
Yes, it is.
And it's the star Polaris. Polaris?
Polaris is the way we say it.
Okay, so
But that's what I just got through calling the North Star.
it's also called the North Star.
Exactly.
Well, it's called the North Star. It's probably in the north.
Indeed it is.
So you've got the North Star, but something very important about this star is that, remember we say that the stars move as you stand outside over the course of an evening.
Yep.
From the left to the right, from the east to the west. And but they actually look like they revolve around one spot.
That's it.
And they actually look like they do this in the very middle of that spot, which is actually due north.
Yep.
North is this particular star,
Right.
Polaris. Polaris.
That's right.
And so it looks like the stars, all the stars, revolve around this one star in the northern hemisphere.
That's
In the
right.
southern hemisphere, there isn't an equivalent.
No, unfortunately.
So they go around and around. And I think maybe we should probably watch a short video of Dr. Boyer explaining, showing us that with our cool
Exactly.
video program.
Let's do it.
But if you look carefully here, there is one star, in fact it's highlighted here, Polaris, that doesn't appear to move. Polaris is always there. Now they just became day so you can't see it. But as it gets evening time here, we're going to see Polaris again. Polaris is the North Star. So all of the stars go around Polaris. Now Polaris itself does move just an ever so small amount, but it is the central star that everything, because this is exactly right above the North Pole of the world. So the North Star, or Polaris, is the star from which all stars, at least appear, they don't actually do this, to revolve around. Turns out that that's how we understand Polaris. They go around Polaris. They don't really go around. The Earth's rotating around Polaris. That's how it works. Now, what do you use to see things? Well, your eyes.
Start with your eyes.
But you know what?
They're not really all that good.
It's kind of cool if you've got a pair of binoculars.
Oh, it
And
makes a huge difference.
you can see cool things. You can take the pair of binoculars that you probably have at your house is better than the telescope that Galileo probably used.
Oh, easily.
So, I mean, we'll talk about Galileo. We haven't talked about him yet, but he's a very famous character.
Galileo could see the rings around Saturn, so with a pair of binoculars, you can do the same.
So if you could find Saturn or Jupiter or something like that, you could see the moons of Jupiter, etc. And of course, there's also telescopes.
Yes,
We have an
the best way to go.
entire unit on telescopes.
Yep.
Telescopes are very, very cool. How the design. This, of course, is sort of a relatively inexpensive one this young man is using right here in our picture. But you can find out so much from binoculars and telescopes and see some really, really cool stuff. So, not a big deal there.
Well,
How do you find stars? You know, if you're out in the backyard, you're saying, what's out there? What stars?
need a map.
You need a map.
Yep.
You know, if you've got a map of the world, it's like, you know, where's Pikes Peak?
Yep.
Well, you'd say, I know where that is. But if you're trying to find something, it's nice to have a map. Well, the stars, well, there's star maps. And
Exactly.
there's ones that are done on paper.
Yep.
And this is a star map on paper. You might notice something odd about this. Let me kind of illustrate some things.
Yeah.
The lines are all curvy. Why do you think they're curvy? Probably because of the ecliptics and stuff like that, right?
Well, is there ecliptic? And of course, the other thing is that the Earth is a sphere, and so is the celestial sphere.
Yeah.
If you take that celestial sphere and flatten it out, well,
Yeah.
you get this distorted map here.
So maps don't work very well with stars, but we have computer programs. And heck, frankly, anymore, guys, you understand if you've got one of these smartphones, you can take
yes.
these smartphones and you can point them up to the sky and say, oh, there's Polaris, there's the Big Dipper, there's Ursa Major. So take your smartphone, download one of those free softwares. You got one of them Droid phones or one of my phones. They're pretty cool.
Yeah.
An iPad. They all do this stuff anymore. It's really getting, the technology is
It's making
getting,
it too easy.
Yeah, I don't know. Well, maybe it's easy, but yeah, that's fine. Or you can use a computer program, like you've been watching us use our computer program. You can use a computer program to figure out where certain things are. Now, speaking of where certain things are, how do we figure out where they
there we go.
actually are? Now, you might remember back to your geography class. And in your geography class, the world has two different breakdowns. There's latitude and longitude, right? Well, we want to now learn how do we figure out where the stars are. Now remember, we take this thing called the celestial sphere right here. And this celestial sphere has the Earth in the middle, and it assumes that all of the stars are equidistant away, and that's how we can figure out where something is in the sky. But it's a three-dimensional object. So we got to say, well, how far is it? Well, what are the things we're going to measure? So let's take a look at that here, and then we'll show you a video clip. So what have we got here? We've got two important words, Dr. Boyer, declination and right ascension. Can you explain what those are?
Indeed. The declination right here is what we would call latitude on the Earth. These lines right here and these lines right here.
So it's like
They match
north-south.
up. It's like a north-south. You're going here north to the north celestial pole.
So up to the
and
north.
then down here you're going to the south celestial pole. And the measurement is called declination. Now the difference is that here we go negative down, and then we go positive up.
So there's not north and south, there's positive and negative.
Exactly.
Okay, so that's not, I can deal with
That's
it.
not
North,
hard.
positive, south, negative.
And the numbers work out. You start on the equator at 0 and you wind up at 90 degrees up here. And at the South Pole, you wind up at a minus 90 degrees. Very easy to remember.
All right, so if I'm standing and I'm looking at a star,
Yep.
I can say he's 72 degrees ahead of me.
Yep.
So that'd be like 72 north.
That's right.
How do I do 72 south, though?
Well, it's a little difficult because at some point you come down to the horizon and you can't see any farther south. There's the limitation.
Okay, all right. And then we've got this right ascension thing.
Ah, yes.
That's like longitude, right?
Exactly. It's
can
the
do that.
same thing as
So it's the
longitude.
numbers over here.
Right?
But, you know, in longitude and latitude, they've got, east and west from the prime meridian. And they don't do that here.
No, not at all.
They do something a little bit weird.
Yeah. What they do is instead of the prime meridian, they start at this point.
What is that point?
It's called the vernal equinox.
Okay.
That is when we have the first day of spring.
Okay, on the
That's
first
March
day of spring,
21st.
on March 21st. Okay.
That's when the ecliptic and the celestial equator cross each other.
Okay.
And this is just a choice that was made by the astronomers to use this.
Okay.
Now, if you go in this direction around the celestial equator, then you see that they have it marked in terms of
H's.
hours.
H stands for hour. Okay,
Exactly.
yeah.
And you go all the way around to the back side here, and you go around in 24 hours.
Well, the Earth rotates in 24 hours.
Yeah, what a coincidence!
Oh, thank
yeah,
you.
how about
That's pretty smart there, guys.
That's right. So you instead of dividing it up into 360 degrees, it's divided up into 24 equally spaced segments in 24 hours. So you start at 0, go all the way around, and come back, and 24 hours back to 0 again.
All right,
Pretty easy.
So if I knew that I had something that was at 80 degrees, and then 6 hours.
Exactly.
I can come over here 6 hours, maybe about right here.
That's right.
Come up 80 degrees, and that'd be a star right there. maybe,
Exactly.
Or a constellation or something.
And that's exactly how astronomers find things within the sky.
Oh, yeah, I can do that.
Yeah,
You know,
anybody can.
Why don't we spend a few minutes, guys, now, and take a look at this up close with our celestial sphere so you can really get a picture of how it works. Okay, guys, I want to talk about the celestial sphere. We've been talking about the celestial sphere, and you're going to do a big activity and you're going to get confused. Hopefully, I'm going to clear some of that confusion up. Celestial sphere, Earth in the center, and we got the sun right here. Now, if you zoom in right here, what you can see, let me pull this out, you can see this little hashy line right here. And I'm going to follow the hashy line. And right here, something interesting happened. It crosses the celestial equator. This is September the 20th or whatever. This is the autumn equinox, the fall equinox. Okay, so if I want to figure out what the stars are out in the sky today, today is January the 20th, I'm going to take the sun, take a look at the sun, and I'm going to rotate that till the sun hits January the 20th. So I see February, and I see January. I move it to the 20th. It's kind of hard to see exactly, but January the 20th is right here. All right, I'm now going to put this in my container, my little jobber here, drop it everywhere. Rotate it so it's easier to see. All right, so I'm at January the 20th, and now I've lost it. Here's January the 20th. I'm going to put January the 20th right here and get the sun right on line. So you can see it's right in line. And what I want to do is now I'm going to pick a time of the day. Now the time of the day that's most likely to go, let's take an evening time. What are the stars going to look like tonight at 9 p.m.? Each of these lines are the right ascension lines, and each line is an hour. So by the way, when I do it this way, this is noon on January the 20th. The sun is perfectly overhead. And then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 p.m. So at 9 p.m., this is what you will see where you live. And by the way, we should also adjust one other thing, is we want to adjust it for the latitude that we happen to live at. The latitude that we live at is about 40 degrees north. Is that right, Dr. Boyer?
Yep.
38, I think. So here is 38 degrees north. And so if you're standing in Colorado at 38 degrees north, by the way, I could turn the Earth so Colorado is facing it here perfectly. Okay, then what would you see in the sky? So now that's kind of the angle that you would see. But while we're at that, let's take a look. I see Gemini, Aruga. Down here is Orion, and Rigel and Betelgeuse. We learned about that a while back. So these are the stars that you could see. Over here you'd see a few other stars. If I move to 10 p.m., I would simply move another hour over. 11 p.m., so let's say midnight. Here at midnight, I can see Hydra, I can see Canis Minor, pardon me, etc. And by the way, you can also see this big swath. This big swath here would be the Milky Way. So you can see the Milky Way tonight. So that's how you use a celestial sphere. Other things you do with a celestial sphere, if you're trying to figure out what you can see, you can rotate it a little bit. And the stars move this way. You move the globe clockwise, the celestial sphere clockwise, when you're trying to do anything, because that's the way things move. So that's how you use a celestial sphere. Folks, that helps you understand how the celestial sphere works. So, but now we want to talk about a different kind of way to measure the stars.
Yep.
There's the celestial sphere methodology,
yep,
and there is the celestial coordinates. Now, how is that different? There's two ways?
There's two ways.
Why do we have a second way?
But this second way is because we like to see things from the surface of the Earth, where the Earth appears to be stationary and the sky moves. So how do I find something in the sky?
Well,
got two ways to do it. As you're standing here.
So that's a person standing on the Earth.
Okay, yes, great. So you're standing on the Earth and you're looking at some object in the sky and you say, oh, it's a certain height up, but how do you measure that?
How about an angle?
An angle, and we call that the altitude. How far up from the horizon do you have to look in degrees?
So if it's at the horizon, it'd be 0 degrees.
Exactly.
And if it's straight up, it'd be 90 degrees.
90 degrees.
So halfway, 45.
Yep.
Exactly. So it's just like a little protractor.
Perfect.
So we could use a protractor. So, Dr. Boyer, and we can take our protractor and we could actually measure that angle. Right
exactly.
There. So if I can move my protractor right there.
Very gently. There we go.
And this way, this blue thing is written, it's roughly 32 degrees.
Yeah, something like that.
So we get like a 32 degrees here.
That's our altitude.
That would be the altitude.
Exactly.
So, yeah, I can do that. That's not terribly hard.
Anybody can do that.
Yeah.
That's pretty neat. Wow.
I didn't mean to get it really that big.
I'm
I was trying to
impressed.
just delete it there. Okay, so that helps us understand. So you got an altitude, but that's not the only thing, is it?
No, because it takes two coordinates to find something.
Okay,
so you've got to have the next piece right here, Z, and that means azimuth.
Azimuth?
Yeah, azimuth.
Azimuth, okay.
There we go, that's how it's... Now, azimuth says, well, let's suppose you're standing here. Now, we're looking at you from the top.
Okay.
And you're looking due south, so your view is due south, and we would say that the azimuth is 180 degrees. And if you're looking due east from where you're standing, that's azimuth 90 degrees.
North is 0.
North is 0. And of course, west is 270,
so
as we see here.
2 different degrees.
Exactly. So it takes two angles to figure out where something is. Where is it in azimuth? And where is it in altitude? Yes.
Altitude. I can get altitude.
Yeah.
There's a kind of a cool internet thing that we want to show that will hopefully illustrate this for you guys. So if we go here on this website, so here what we've got is an azimuth thing. So here's a guy standing out here, he's looking due south, and here's a star, and I can move that star. So let's say the star is there.
Oh,
and
wow.
now if you look here, his azimuth is 121 degrees, altitude 20, so up here,
from
here to here is 20 degrees, right?
Exactly.
And then he's 121 degrees from north, so that would be
there it is.
There.
That's right.
And that's the 121 degrees. So that's probably easy. That's easier than that celestial sphere, isn't it?
That's because this is the perspective we're familiar with, whereas a celestial sphere is not a perspective that we like to think of.
But the problem with this is that the stars move.
The stars move.
So it might be 121 degrees.
That's right.
But in a few minutes, it's going to be 122 degrees.
Exactly. That's the
By the way, the 20 won't change, though, will it?
The 20 will change depending upon which star you're looking at.
Oh, I thought it didn't change.
So,
okay, never mind. I was wrong. Okay, so they change because the stars move. So this method, though, it's most convenient when you're standing outside.
Right.
And you know what time of night it is and such.
Yes.
But one thing, again, if you got your smartphone, you can just point it up. It's getting too easy, Dr. Boyer, you're right. But if you knew that you were supposed to turn north and then go 125 degrees, up 30 degrees, you could find a particular star.
Exactly.
If you knew his address, so to speak. So this is just kind of a way to find the address of a star. I think we've just got a couple more things to talk about.
Yes.
Planetary configurations. This is something else that does happen. So there are different kinds of configurations. They're what we call actually conjunctions is the topic here. Okay, and so we have inferior, actually let's talk about superior. So you are here. This is the Earth. Sometimes a planet, this is about planets, is between you and the sun. So right here is a planet, and this would only work with Venus or Mercury.
That's right.
And so you can have an inferior conjunction with Mercury. So it's between you and the sun on a particular time of the year. Sometimes they're going to be opposite you, opposite the sun, the other side of the sun, and that's called a superior conjunction. And sometimes you have them behind you, and that's called opposition when it's behind you. So here's the Earth, and here's Jupiter, looks like to me. You can also still have a superior conjunction of Jupiter when it's on the opposite side of the sun. Now, Dr. Boyer, what the heck is this elongation thing? You want to explain that to us?
The elongation has to do with the fact what happens when this planet moves around the sun, but it's not in an inferior or superior conjunction.
It's in the middle.
Then we say it's in elongation. This section right here and this section right here is when it's an elongation.
Now, didn't that kind of help scientists when they were looking at the phases of Venus?
Exactly.
So like it has crescent shapes and stuff like that, like our moon?
When Galileo looked at Venus, he saw that it had phases. He was tracking Venus as it went through its elongation all the way around. Now, our directions here, we have eastern by...
No, it's on the east.
Well, from our perspective,
Yeah.
if this was, say, like north, then we would have
Yeah.
east and west. Now, this greatest here just simply means it's this position right here, when it's the farthest to the
90
side.
degrees.
Exactly,
Yeah.
90 degrees.
I see.
Yep.
Okay, very cool. And I think we're going to want one more thing to chat about, guys, and that is that I think we're done. And so we're finally done with the 1.1 podcast. By the way, remember 1.1 has to do with section 1.1 in your textbook. So use 1.1 in your textbook if you get lost. Have a good day.
See you next time.